Good afternoon, everyone. My name is Dr. Stephen Robertson. I'm the Administrative Executive Officer for the National Society of Black Physicists, and I would like to welcome you. Oh. I didn't even say where I was from or anything like that. Oh, but I would like to welcome you to this afternoon session. So thank you all for coming. And I hope, how many of y'all are enjoying the conference so far? Well, that is fantastic. I'm glad that you're having a great time. So I would like to recognize all of our sponsors and thank all of our sponsors. If you are sponsoring this conference and you would like to, would you please stand so that everybody will know who are the sponsors for this conference? And please give them a round of applause. We would also like to thank the 43 exhibitors that are supporting this conference. Are any of the exhibitors here? Please stand so we'll know who you all are. Thank you again. Their support is what allows us to get on have the students come for free and stay for free. So the students, give them some love. And now it is my deep honor to present our student representative, Miss Farah Simpson.
Hi, everyone. I am the immediate past student representative, and it is my pleasure to introduce our luncheon speaker, Dr. Asmeret Berhe, who is the director of the Office of Science at the U.S. Department of Energy. She is on leave from the University of California, Merced, where she is a professor of soil biogeochemistry, holds the TED and Jan Velasco Chair in Earth Sciences and Geology, as well as serves as the Interim Associate Dean for Graduate Education. Dr. Berhe's internationally recognized research lies at the intersection of soil science, global change science, and political ecology, with an emphasis on how the soil system regulates the Earth's climate and the dynamic two-way relationship between the natural environment and human societies. Dr. Berhe's expertise on feedbacks in the Earth system brings a unique perspective for integrating across the physical and natural sciences. Dr. Berhe's scientific leadership has been recognized by multiple national awards. She is a fellow of both the American Geophysical Union, AGU, and the Geological Society of America, GSA, and has received numerous awards and honors, including the Joan Simpson Medal for AGU, the Bromry Award for GSA, and was selected as a new voice in science from the U.S. National Academies of Science, Engineering, and Medicine. She's also a founding investigator of the Advanced Geo Partnership, a National Science Foundation funded effort to empower geoscientists to transform workplace climate through interventions to reduce harassment, discrimination, bullying, and other exclusionary behavior in research environments. Please help me in welcoming Dr. Berhe to the stage.
Hello, everyone. Thank you for that really kind introduction. Really excited to be here with you all and join in this amazing conference. We've only been here a little over about an hour or so right now, but it's already clear how amazing time you're all having and got to hear a couple of really good presentations from students. So thank you, and really feel honored that you all invited me, and I'm happy to be here. I'll start by sharing a little bit about my background and who I am, and now also about my current position at the Department of Energy that I'm hoping many of you are very familiar with. If not, at least I'm hoping to introduce you all to a little bit of what my current job entails. And I know there are other colleagues from the Office of Science who'll speak in the panel later in the afternoon to give even more information about opportunities that exist for all sorts of work and research opportunities at the national labs. Okay. So I'm going to try, as I mentioned, to share a little bit with you today about my background, my passion, the kind of things that I love to do in my scientific role, and also the Office of Science, or SC, as I mentioned, and try to share with you the different things that we're working on right now in our efforts to kind of advance science and technology across the US S&T landscape. We're trying to enhance, obviously, many career and science experience opportunities for not just students at different levels, but also teachers, researchers, and even mentors across the country to come and work with us at the Department of Energy with some of the incredible labs that I'm assuming many of you are familiar with that I'm going to tell you more about. And as I mentioned in the intro, I'll also try to tell you a little bit about my life journey and who I am and how I got to this point in the first place. Okay, so let's start with this. It's a long list of basically appointments and education that I got along the way. But I just want to start by saying that I was born and raised in Eritrea. Show of hands, how many can place Eritrea on the world map? Yay, very cool. It's a fairly new country. So I don't blame anybody for not knowing exactly where it's located, but I was born and raised there, did an undergrad in soil and water conservation, then moved to the US and studied at both Michigan State first for my master's in political ecology, where I was working on political ecology of land degradation in particular. And, you know, I'm a soil scientist. I love soil. Unapologetically, I will burn your ears and make them full if you give me a chance, and I'll talk about soil until, you know, the end of days, if you will. But I'm also a scientist who realized when I was doing my undergrad that as we're studying the physical and biochemical basis of why and how soils get degraded, we don't get a very good glimpse into how humans enter into the equation. How human relationship with land actually has a lot to do with how human communities around the world have significantly degraded the world's soils. You know, I think many of you appreciate that, you know, that soil is where we get our food, right? 95% of all the food we consume either comes from plants that grow in soil or animals that call the soil, you know, that eat from the plants that grew in soil. But beyond that, the soil system also plays major roles in regulating our climate. It's the reason why you and I are able to drink clean water relatively easily. It's the most diverse and a place where there's most abundant life that exists in the Earth system. So just to give you a few numbers, if you hold a handful of fresh soil from a healthy ecosystem, think of a forest topsoil, for example, in your hand, you're likely to have just in the soil that's in your hand, you're likely to have something on the order of about 10 billion with a B individuals of living things in that soil. And those individuals can come from up to 10,000 different species. It's a mind-boggling level of diversity. There is just no place in the Earth system that supports that much life and abundance. And that means that the soil system is able to regulate a number of key biochemical reactions that control our climate, that control our recycling of nutrients and everything else in the Earth system. And that's also kind of what brought me into the national lab system. I'll tell you all in a minute. But you know, so that's why I wanted to understand after I did my degree in soil science and was, you know, kind of felt comfortable with how I understood the physical and biochemical basis. I wanted to understand how humans entered that equation. So that was what took me to Michigan State to do political ecology, which is a study of basically applying political economic theory to issues of how humans interact with natural resources. Then I decided I'm going to go back to the mostly chemistry, biogeochemistry work that I loved. So I pursued a PhD at UC Berkeley. And that was a really wonderful opportunity for me because not only was I getting amazing education in soils that I cared about, this time with a focus on the role of soils in regulating the Earth's climate, but I also had a mentor up the hill from Berkeley at LBL. And that mentor introduced me to the National Lab System. I didn't really know when I started graduate school in Berkeley, I didn't really know a whole lot about the National Lab System. She introduced me to the Lawrence Berkeley Lab, but also introduced me, even more importantly for my career, to opportunities that exist in other labs. So with her, we wrote user proposals to go and use advanced spectroscopic tools, in particular NMRs at the Environmental Molecular Science Lab at PNNL, which to this day remains one of the most advanced places where you could do spectroscopy, especially on heterogeneous mixtures like soil. And I spent weeks at a time at PNNL running the instruments and learned so much more about the National Lab System and what exists. And since then, I've continued to work and collaborate with folks in national labs, even as I pursued my academic career at University of California in Merced. And what I tell you this because my hope in starting this conversation, and hopefully we'll have a lot more, is so that you also get to know about the opportunities that exist at the national labs, in case you're not aware yet. And also tell you a little bit about new opportunities we're opening. So as I pursued my academic career, and into this day, I don't want to pass without acknowledging that I'm a Black woman. There aren't a whole lot of Black women in geosciences. Our thank you. Thank you. Yeah. So our field, geosciences, and you all in physics, our fields have never been blamed for being diverse, right? We we all agree on that. So this is why I uniquely appreciate being here and seeing the community and you all spending time together. We have similar communities in the National Society for the National Association for Black Geoscientists and others in my field too. So I really, really appreciate what it means to spend time in this community and with people who understand your path and understand the challenge also that we face along the way. Okay. So I was doing my academic work, pursuing, a number of topics that I care about in addition to my research, especially topics around equity and inclusion. When I was approached about this position of the director of the Office of Science, I would be lying to you if I said I didn't for a second hesitate. Do I want to do that? Do I want to work in government? But I saw an opportunity to at least inject a voice that is typically underrepresented in science at the highest levels. And I figured, well, I've been talking a good game about what we need to do to improve conditions in the science and technology, STEM overall communities. So this is my opportunity to try and help in that effort in a major way. So here we are. I am currently serving as the director of the Office of Science. It's been about 6 months now. And I tell you, it's been quite a whirlwind. It's been an incredible pivot from my academic position, but also exciting. Just in the last 6 months, among the many wonderful things we were able to do, we celebrated the Frontier High Performance Computing System at Oak Ridge National Lab, which currently stands as the fastest high performance computing system, which is also the most energy efficient in the world right now. And that was amazing, as you can imagine. We also launched a number of efforts around climate and clean energy, including a new initiative called the Urban Integrated Field Labs. And these are slightly different kinds of initiatives where the scientists at the universities and labs are not just working with their partners, other scientists, but they're actually thinking and working with the communities they live with so that they can understand the climate-related challenge that the communities are either facing or about to face because of predictions. and think together and work together about addressing it. It's not the kind of thing that the Department of Energy supported projects had done in the past, but it's a really important start because, as I could tell you from my own academic and research background, voices of people who are likely to be most impacted by climate change are severely underrepresented in the places where we make decisions, where we have important conversations about which way the science is going, or even the implications of that. Even though I can't take credit for the launching of the urban field labs, because a lot of the work for this happened before I arrived at the DOE, but still, as I think I recognize as an important partnership. We also awarded $500 million funding for energy frontier research centers and clean energy manufacturing centers, which are basically leading the science underpinnings for the materials and the energy sources and storage of energy that are needed for addressing the climate crisis with the kind of seriousness and urgency that we need to address it. Some of you in the fusion world might have also heard that last spring, DOE, in partnership with the Biden administration and other parts of the government, and even some private partners, have launched the bold decadal vision for fusion energy, the promising, potentially clean source of energy that we're all hoping will address climate change and related issues in a major way. And even more, right? We get, for example, when I finish here in a couple of days, we get to visit ITER, the International Fusion Experiment that's located in the south of France. That's the picture at the bottom right of your screen. So it's been an incredible opportunity for me to sometimes be a scientist and just learn about new science areas or more work in my area of science. Every once in a while, be an administrator, obviously in the role of the director, but every once in a while also be a diplomat representing the US delegation, say when we're heading to places like ITER. Okay. And just to tell you a little bit more about the DOE Office of Science, then our mission is to advance the frontiers of science. We are the largest supporter of basic research in the physical sciences in the entire nation. We're an agency of about $8 billion budget, and obviously play the major role in advancing the frontiers of science, in advancing the DOE missions around energy and a number of areas related to the physical science underpinnings, including in areas of physics, obviously. We also have a major role in serving the nation's scientists. We provide a lot of the funding where research, including in physics, is done. And as a result, we take that role of serving the nation's scientists very seriously. And an important way that we serve the nation's scientists is one of them, for example, is that we provide obviously funding in terms of fellowships, grants, the major ones, both to university researchers and national lab researchers. We fund a number of user facilities that serve many tens of thousands of individuals per year, not just from the US, but even internationally. But we also run important facilities. So for example, the 10 of the 17, the national labs that the Department of Energy has are stewarded out of our office, which means those of you in NP, for example, if you're doing work at the Thomas Jefferson Lab or others, these are labs that we steward out of the Office of Science. And the program managers and the associate directors for the programs are actually here today, and you'll be able to hear from them later. So a lot of really cool things. And the work that we do spans these 8 areas. So we're talking about the Advanced Scientific Computing Research Program, including the program that made possible that exascale high-performance computing system that I mentioned earlier, the basic energy sciences, everything you can think of around chemistry, physics, material science, even geosciences, and then the biological and environmental research, or BER, where a number of the bio and environmental related work is supported from. We're talking about fusion energy sciences, high energy physics, nuclear physics, but also accelerator production and research programs. So the accelerators that you all use, many of you in your research, we don't just buy them obviously and install them in places. We actually have programs that support the research that goes into them and producing them. In the same manner, we do similar with isotopes, very many stable and radioactive isotopes. So we support the work that goes into basic science, but we also enable the production and provision of these critical isotopes for many, many areas. And so there's a number of many amazing things that we're able to do in this work, as I mentioned. And here I'm trying to give you a couple of really exciting flavors, if you will, of the kind of work that the Office of Science enables, which by no means is an exhaustive or even a representative list, just a sampling of it. So recently, for example, in this picture that you're looking at, researchers at the Thomas Jefferson International Accelerator Facility, these are nuclear physicists, use new and first of its kind precision measurements, for example, of the nucleus of a rare calcium-48 isotope, and we're able to determine how its protons and neutrons are distributed inside the nucleus. The experiment found that calcium's protons and neutrons aren't simply sprinkled throughout the nucleus, but instead form this neutron-rich thin skin around the core of a more evenly distributed protons and neutrons. And scientists at TJ Lab are working obviously with many of their collaborators and using this to compare to pre-existing theoretical models that had previously predicted that it was supposed to be the other way around with a thick neutron skin, as they'd previously seen in lead, with many fundamental implications of why they're doing this kind of work. And another example, team of researchers from the Stanford Linear Accelerator Center, SLAC, National Accelerator Lab at Stanford, and working with their collaborators at Stockholm University, were able to employ a mega electron volt ultra-fast electron diffraction instrument at the Linux Coherent Light Source, or LCLS. And they use this pretty much what they characterize as high-speed electron cameras there to investigate the water's hydrogen bond structure and its dynamics. And the experimental results revealed quite unique effects, such as how the contraction of the hydrogen bond emerged upon laser excitation of the nuclei. This finding is, of course, exciting in itself. We are excited about basic science because it's just cool in itself, but it also reveals a lot of really critical aspects of microscopic origins of water's strange properties, and even they're looking into potential of how this affects how water helps proteins function inside living organisms. And understanding the quantum behavior could also be important in modeling many of the critical reactions that involve hydrogen, for example, including formation of hydrogen, carbon bond and activation, water excitation, and even reduction of carbon dioxide and other acid-base chemistry that's critical for energy-related phenomena. And as a scientist, I find all of this exciting, right? Because every day there's something new that I'm learning, even things that are completely outside my field. And as I mentioned, what makes this exciting is we're not just supporting research at the universities that can also be doing interesting and important work, but we also get to support and steward 10 of the major national labs. So as you see in this picture, the green ones are the ones that we steward out of the Office of Science, and they include, the Lawrence Berkeley, TJ, as I mentioned earlier, SLAC that I also listed, but also Brookhaven, Oak Ridge National Lab, Ames, and a number of these labs that you all, I assume, spend a lot of time in. And I wanted to ask, how many of you have spent time at a national lab so far? Very cool. That was transformational for my own PhD and scientist journey. So I'm really glad to see that. And what is really exciting to me is that there are these scientists that are at the top of their fields, obviously, in the national labs, doing some of the most advanced scientific work in the equally advanced facilities, right? And they're vibrant communities that I think can play and should be playing even more role in advancing the science missions of the country, which means supporting the workforce and supporting a lot of the really cool work that the next generation and the students that are right now studying conduct. And then the other one I wanted to just briefly mention is that within these labs, I mentioned the office supports many user facilities. And here's a sample, here are what they look like, 28 of them in the 10 national labs. And these are incredible facilities, right? Literally some of the best that exist in the world. They were talking about light sources, neutron scattering sources. We're talking about the most advanced spectroscopy possible, genomics facilities, and many, many others. How many of you have written or spent time, let's start, in user facilities in the labs, not just working with scientists, but in the facilities? Not as many, but next time you're in those national labs, make sure to learn more about the user facilities, because these are facilities that the Office of Science, for example, supports, so that they're freely available to you all to do your work. All you need to do is find a collaborator, write a short proposal, what they call the user proposals, so that you get access to time. But in addition to the time that you need on the instruments, you also get time with scientists that are the best literally in their field. So they allow you to do the work and teach you in the process, and they become your collaborators. So if you haven't done so, I encourage you next time you get an opportunity to learn about the user facilities and see if you can find collaborators there, because I think those are some of the most amazing things that we could provide. Now, allow me to switch gears a little bit and talk about priorities of the Office of Science, including my priorities of things that we're hoping to accomplish during my leadership. I'll go over each of these priorities in detail, but I want to state that a lot of these are guided by the belief that I personally have and hold dear, that publicly funded science should be able to support the whole public. I know that's a bit of a radical statement. Thank you. I know that's not a very radical statement, even though I can understand some might think so, right? But let's be real, that's not how science has historically operated. And we're trying our best to make sure that it doesn't have to be the way forward. Okay, so first off, some of you might have heard that Congress and the Biden administration have provided us with amazing new tools to enable the science that we support at the Office of Science. I mentioned earlier that we're about an $8 billion agency, and in the CHIPS and Science Act that was recently passed, Congress authorized us to spend about $50 billion over 5 years. That's a much higher budget, obviously, every year, right? And we're, that would allow us to expand both our potential support for the discovery research, that is our bread and butter, the basic research, right? But also allow us to expand some of the roles that the Office of Science can play. We're DC adjacent, so I'm kind of required to remind you all that in DC speak, authorization does not mean real dollars. It just means we're authorized to spend up to that level. There's an important step that has to happen before we can get there, and that's the appropriations. And it's my top priority and the top priority of everyone in the Office of Science and DOE right now, that we get the appropriated budget gets to match or hopefully get very close to that authorized level, because that would allow us to support Office of Science and provide you all with the robust support that we could provide you to advance critical missions and research you're all working on. The second topic I want to talk about is the Inflation Reduction Act, or IRA, that I'm sure you've all heard about this in the news, right? All over the news, especially today. And the Inflation Reduction Act, in addition to providing funding to allow people across the country to cut healthcare costs, lower energy costs, and even build a clean energy economy, it provided the Office of Science with $1.55 billion to support Office of Science lab infrastructure, in particular to support ongoing projects. This is a huge deal. The labs and the facilities that we steward desperately need resources to modernize, to support the facilities and the infrastructure. And this was welcome news by everyone. In the last 2 weeks, for example, we've made major announcements related to this, both at Oak Ridge National Lab and Argonne. And the Argonne announcement, in case you haven't heard, was more about all of these things, that all of the projects that these $1.55 billion is going to be able to support across the lab complex. And at Oak Ridge National Lab in particular, we broke ground on a new stable isotope production and research facility called CIPRC, which is really going to provide critical stable isotopes that are needed for health, the microelectronics sector, and a number of them that are critically needed in the research areas. And the Inflation Reduction Act and hopefully the higher level of annual appropriations that we would ensure for the Office of Science budget is really critical for us to ensure that we provide adequate support for the national labs, which I really believe are the crown jewels of the American science enterprise, and can continue to play an important role to enhance the scientific community, to enhance the support that they provide for the needs of the American science community, to continue to make sure that you all stay and continue to be productive and competitive in the global landscape. So just to give a little bit more detail, the increased funding that we are working towards would also enable us to do much more that we want to achieve, including to drive, of course, the frontiers of science forward, as I mentioned, but along that effort, we're also working very hard to make sure that we develop a strong 21st century STEM workforce, but do it in principles that are rooted in belonging, access, justice, equity, diversity, and inclusion. And I mean this in a way that we don't just talk from our perch somewhere that we're going to provide funding for DEI, and then some institutions going to make a glossy statement on nice sounding, but actually walk the talk and deliver with every project that we're supporting and every dollar that's going out of the door in the Office of Science, that we're thinking about how we're making sure that our research is providing support and providing research support to everybody in an inclusive manner, and that we're not leaving anybody behind. Thank you. As you can imagine, this is a core priority of mine, not making any secrets about that, obviously, right? But it's thankfully also the priority of the Biden administration. It's the priority of the Office of Science. It's the priority of the Secretary of Energy and the Department of Energy. Everybody's working towards efforts that are to ensure that the science community becomes more inclusive, right? That we're ensuring that the pathways to resources that the Office of Science provides are accessible to people from all different backgrounds. Whether you get support from us or not should not depend on what institution you attend or what kind of background you have. We should theoretically have open doors to everybody so that everybody gets a chance to learn about what we do and do their best, obviously, to get the support that we're trying to provide here. And an important part of this to me is that we're doing everything we can to reach communities that have been historically underrepresented and minoritized in STEM fields. And do so by reaching out and making sure that we're providing the information that those communities in particular need and the support that they need to make sure that they can participate and take advantage of the resources we're providing. It is my goal that during my tenure as the director of the Office of Science, we will make a substantial and demonstrable difference in the participation of folks from historically underrepresented and minoritized communities in our programs. I hope this, thank you. Yeah, not being radical, but again, publicly funded resources, right? I think it's extremely important that we're actually allowing all the public to have an important chance in here. Yep. And a big part of this is a new requirement that we added that some of you might have heard of. We call it the peer plan or peer, and this initiative was launched last month, which means in FY 2023, starting from this past month, the Office of Science has added a requirement to all applicants so that when you submit a proposal to us, you're also submitting a plan for how you're going to promote inclusive and equitable research or peer plans, along with that research proposal that you're submitting. This is a requirement for all solicitations, funding opportunity announcements, DOE lab announcements, as well as for invited proposals from DOE labs. We also have similar requirements for conference proposals to make sure that the conferences we support also are applying these principles of equity and inclusion and accessibility, very important. We're taking, as I mentioned, very similar approaches because we want to make sure that, say, for example, when people show up in conferences, that the applicants and the venue where the meetings are held will have established codes of conduct, including anti-harassment, anti-discrimination, and bullying policy, and tell us how they're actually going to enforce it. Don't just say you're going to do it, but actually how it's going to be enforced, because we want to make sure that when we're providing public support to folks to attend meetings, public support for folks to do research, that it's being used to open doors, not to close doors and discourage people from staying active in the scientific community. Thank you. And we want to make sure that those conferences also are thinking about accessibility plans and plans for inclusivity in how they select speakers, how they provide the resources that the attendees will need to actively participate. I know a lot of people will worry every time you talk about topics like this. Are we now, all of us are going to have to be diversity experts or something along those lines? I think many of you know that this is really something that many agencies already had, right? DOE didn't have this requirement, obviously, until now, but NSF and the other peer institutions already have them. And the message there is, we're not expecting you all to be, all the applicants to be experts in diversity or inclusivity, but we want you to think about how you're going to work with the institutions that you're part of and your community so that we can provide approaches and experiences for people from different walks of life and just make sure that environment is inclusive and safe for everybody. And again, we're in an effort to make sure that we're not just announcing things and not supporting folks to meet those goals. We've provided many webinars, website that's rich with information at this point, office hours by the program managers and others. And so there will be plenty of opportunity for support if people need it. I invite you all to please be part of these conversations, visit the resources, and tell us if we could do something better. We really would like to make sure that we get this one right. It's really important. Okay. And another thing that I want to mention is also that we provide a number of resources through the Office of Workforce Development for Teachers and Scientists, WDTS. This includes things like short-term internships for even undergraduate students to work in labs, but also even fellowships that go from anywhere up to 3 months to a year through the Office of Science Graduate Student Research Fellowships, or even longer fellowships that are provided, for example, through the computational sciences programs, and a number of other efforts aimed at opening our doors to teachers and scientists so that more and more people learn about the opportunities that exist at the national labs. I don't know how many of you know this, but this office also runs the National Science Bowl, the national competition for middle school and high school students across multiple science topics. Really exciting competition in case you were not familiar. Okay, so a number of opportunities that are available. And the other thing that I wanted to talk about is that this fall we launch a new program, and then one that was launched last fall too. These are called Renew and Fair. Renew is a program. Renew stands for Reaching a New Energy Science Workforce. And FAIR stands for Funding for Accelerated and Inclusive Research. And they're meant to fund students and researchers at historically underserved communities, including MSIs and HBCUs. And the idea here is that through Renew, we're providing research funding for students and researchers. But through FAIR, we're also providing resources for capacity building at those institutions. The institutions historically do not have the kind of federal support for research that many larger institutions would have. These two initiatives are laser focused on equity and making sure that we're engaging students that were historically underrepresented and from communities that are minoritized in the different fields of science that we support. And again, across these and other fields, we're really interested in working with people so that you all know what we're thinking and how we're trying to implement it and support you in your efforts. We fully recognize that sometimes what stops people from applying, especially when you work at a smaller institution, is really not having access to the staff and the mechanics that is needed to actually make proposals work in sponsored research offices and things like that. So if you have issues and questions like that, if you're people in your community that might have, reach out to us. We're trying to make sure that this doesn't become a barrier that prevents people from applying to the opportunities. Oh, sorry, I went back one too fast. The other thing that I am very, very passionate about is science communication. I think as especially scientists working in the public sphere, we have a responsibility to share the wonder, the awe, and the implication of the work that we do with the public. I think that includes the general public, whatever that may mean, but also policymakers and our broader community. People we live with, our neighbors, should know about the work that we do, or at least the fact that we're scientists and can tell them, stories that would get them to excited about why science is so important. And my hope and an important goal that we have in the Office of Science is that we're invigorating science communication so that we share that wonder and awe with as many people as possible. And we also want to make sure that the stakeholders, especially policymakers that we continuously are going back to for support, understand why it is important, why it is such critical for the science and even for society that they continue to support the basic science and basic research and even research in other areas. An important part of this, and one that I'll share especially with the students and others in the field who might be passionate about this, is we don't typically learn to tell good scientific stories in our graduate education. It's kind of one that we have to practice ourselves, especially when we're earlier in our careers, or even later, to be fair. But if you haven't done that, if you haven't kind of practiced and try to think about, say you work in a very basic fundamental field of physics, things that are very hard to describe, let's say without 50 equations. Can you think of a way to help people understand? Maybe it's an analogy, maybe it's something, why it is important. I think the way I think about it, an important goal of science communication is to share with people that wonder. Right? Think about, for example, how a lot of us see an image of a Milky Way and some kind of galaxy out there. Doesn't have a whole lot of connection with our lives down here, at least not direct ones, right? But we're awed because of the possibility, the stories that it tells about and what it takes, the hard work that is needed to get there. So if you haven't thought about your work like that, I really encourage you all to continue to do this, because science communication, like everything else, it requires practice, right? I'm a soil scientist, so I've had to learn to grab people's attention when I'm talking about soil, because let's be real here. The minute I mentioned soil science, many of you here thought about dirt, right? And you wondered, is she really that excited about dirt? Like, some people did, at least, right? So I have to start by telling people why it is important that we think about soil before the fancy biochemistry that I do, or chemical reactions that I'm trying to communicate, before they can even get a chance to understand them, before they can even grasp that literally the only thing that stands between life and lifelessness in the earth system is that thin soil layer that's covering the land. And that's also responsible for maintaining our climate. But before I can help them understand that, I have to get their attention with soil in the first place, to give it a chance, right? So that meant in my career, I've spent a lot of time trying to think about how to communicate the importance of soil with larger communities, even scientists, outside earth and environmental scientists, who never really stopped to think about, why that's important, right? I was like many of you, before I started my undergrad, I didn't even know there was a science to soil. Then I took an introductory course in soil and I was hooked. I never turned around. I've been studying soils since then. I'm not going to tell you how long that's been. The white hair here tells the story by itself, but you get the idea, right? And I think it's so important for us to work on that. I had a wonderful example of that as we were touring the poster session and hearing about a neutrino research that was done with the detector in Japan from a student here. That was just wonderful. And I really encourage everybody to think about those kinds of questions if that's not what you've thought about before. The other really important message that I've tried to convey since taking this role is that we have incredible resources and capabilities at the Office of Science. And I think we're at a point in time now that humanity cannot ignore climate change. I'm not just saying this, thank you. I'm not just saying this because that's been my life's work, right? Trying to help understand climate feedbacks and interactions in the Earth system. But I think it's extremely important that all of us are engaged in this. And to me, that means we're bringing to bear all the capabilities that we have, and that when we're thinking about doing our work, setting our, extremely complex experiments and other things, that we're thinking about how can we make sure that this is the most efficient approach possible. Yes, it might cost a little bit more money, right? It might take a little bit more time, but at the end of the day, it's worth it because we don't want to leave behind a planet that's not livable, right? And it's also important for me from an equity perspective. I mentioned earlier that the victims, the people in the world that were going to suffer the brunt of this climate crisis if we do not get our act together are brown and Black people who had nothing to do with the crisis and creating the crisis. And we can't all stand by and think about how it doesn't affect us because it's affecting other people many of them in our communities. They just happen to be a little separated from the academic or research side of things that we do. And this is also an important reason why the president's agenda in tackling the climate crisis at home and abroad, even the executive order that was published by those same title, created something that you might have heard of called the Justice 40 initiative to ensure that one, we're doing everything we can to address the climate crisis. And second, that we're directing 40% of the overall benefits of certain federal investments to flow to disadvantaged communities. Make sure that as we're addressing this crisis, we're also addressing it in a way that makes sure that we're considering impacts on underserved communities. So the Office of Science, in close partnership with the Department of Energy, is more connected than ever to think about how the basic science that we have worked on always connects to applied research, development, and even deployment programs related to clean energy and renewable energy in particular. There's a number of efforts cross-cutting across the Office of Science, many of them coordinated actually at the level of the Undersecretary of Science that I report to develop what they're called Earth shots. So this is the idea that President Kennedy had about reaching the moon in the 60s, the moon shot, and this is the Earth shots. What can we do to make sure that we launch a lot of these initiatives in a way that they're going to successfully address the climate crisis by making them accessible, by making them efficient and scalable, and also cost efficient. So there's a number of efforts now related to decarbonizing, carbon negative shot, for example, hydrogen shot, long duration battery, and a number of other areas that we're engaging in a lot of conversation. I'm going to stop here, but I'd like to, before wrapping up, to thank you all for allowing me to share my vision and really appreciate the opportunity to be here with you all. Together, I really believe that we can build an even more amazing community and do incredible work to continue kind of the legacy of people that came before us as supported by the Office of Science. As long as I'm in this position, to reiterate, right, my goal has been to make sure that to bring all voices to bear on critical science challenges, making sure that we're using those voices to share the wonder, the excitement, and important implications of the work that we do, and ensure that we're bringing all our capabilities to bear to recognize and address some of the biggest challenges humanity is facing right now. Typically, when she's talking about this, the Department of Energy, Secretary of the Department of Energy, Jennifer Granholm, says DOE is the solutions department. And she talks about, and I really like that the Office of Science is where actually those solutions start with basic science, with the science that many of you contribute to and are part of. So I'm really thrilled to connect with everyone here, really appreciate again that opportunity that I got to share what I'm working on and who I am with you all. And I'm hoping this is a start of a connection and not the end of it. I'm going to remind you all before I end that on the afternoon panel, associate directors and program managers from both our offices of nuclear physics and high energy physics will be here. So they will be able to share a number of opportunities and insights, information with you all. But by all means, please reach out and I'm happy to take any questions you might have now. Thank you. Thank you all. Thank you, everyone. Thank you. Thank you. Really appreciate you. Thank you, everyone. Really appreciate it.
Okay. All right. Well, thank you once again for such a great talk. We have time for a few questions. So if you have a question, please raise your hand.
There's one right here.
Hello, my name is Kirk Kennedy. I'm a student at Morgan State University. I was wondering what novel discoveries or findings coming out of the national lab system give you the most hope in terms of confronting the climate crisis?
So I'm a little biased in that answering that question because I think the way, in my opinion, we should be addressing the climate crisis right now is something that I like to call an all hands on deck approach, right? I don't think we have any more opportunities to focus on one opportunity or another. We have to actually deploy every possible solution that we can think of, and especially think of the nature-based solutions. And that's what I meant when I'm biased. That's been my life's work. But the reason why I think that's important is because think about the fact that we still have to address the climate crisis. We still have to feed a growing population. But the world's resources that we depend on for our needs, for food, feed, fiber, are continuously getting degraded. About half of the world's soils right now are considered degraded, meaning their capacity to support plant production is compromised, their capability to actually take out CO2 from the atmosphere and sequester it in long-term pools so that it's no longer going back fast into the atmosphere as greenhouse gases is compromised. So to me, if I were to rank a few things, I would start with those nature-based solutions because those are critical to address the climate crisis, but they're also critical to ensure that we're also going to continue to eat and read the resources that we need. But having said that, there's also a number of efforts for literally pulling out CO2 from the atmosphere, but also making sure that the energy sources that we use are cleaner. There's a number of exciting opportunities and discoveries related to hydrogen that are coming out of the national labs. but also long duration storage. So batteries that don't rely on critical minerals, batteries that can last longer, batteries that just perform way better than the ones that we're relying on right now. In particular, the ones that are showing promise to work with clean energy sources. And so I think those are, it's one of these things where right now we're at a time where there's so much good happening in terms of the advances and discoveries, but we need to be able to scale it. And that's what these energy earthshot approaches are supposed to do. Scale it to the point where it's going to make a difference at a scale of like gigaton of CO2 and things that we can remove from the atmosphere. And then make it last, make it stay in those stored pools so that it's not just quickly cycling back into the atmosphere as greenhouse gases. Did I answer your question? Cool, thanks.
We have a question from someone online, Nicolette. What advice would you give to undergraduate students wanting to get involved with the DOE?
That's a great question. My advice to undergraduate students is to find research opportunities. But I understand that if you're an undergrad, there's probably a chance that you're not sure where to find them. So the first place I would advise you to go is the WDTS office at DOE, the website for WDTS. There's a lot of information provided there. And even if you need connection with people at a specific national lab, you can reach out to those folks or folks within the Office of Science who would happily, forward your message to the lab. And the folks at the labs are always really great. There's a number of opportunities and being expanded. And the message is out there. It's not, as I said, it's not just me trying to broaden participation. The labs are working really hard, the department as a whole. So they're expanding opportunities in many, many places. But if you can't see any opportunity that fits for you, feel free to reach out, tell them what you're interested in, and then ask them to connect you with folks in the labs. And they would typically connect you with another researcher or even students, other students that you might be able to share information from.
Okay, do we have any more questions?
Okay, I've got the mic, so can I go?
Oh, yeah, sorry, didn't see
Hey,
it.
that's okay. Hi, I'm Latanya Pegues. Totally enjoyed your presentation.
Thank you.
So really excited to see that you are there representing in so many ways. So again, congratulations.
Thank you.
My question is revolving around the, and by the way, excellent as far as like all the DEI, I know the President Biden has the executive order to advance racial equity throughout the entire federal government. So just to see how you have, have your case in front of us, it's very impressive. So my question is revolving around the enforcement piece, because for about 50 years, we've been talking about equity in so many different ways, inclusion in so many different ways. But when it's time to actually show, that the work is being done, then all of a sudden there's, like no evidence for that. So just curious as to how you plan to do the enforcement piece, and also just to make sure that, because there are systems in place that they say, if you don't meet these goals, you are not supposed to get any more work, and you're supposed to be on a quote, bad list is what I'm calling it, but it's something else. So just really curious as to, what your plans are there, because somehow there's always pushback when it's time for us to move forward. Thank you.
I hear you. I think I'll start by acknowledging that over 40 years worth of federal funding that has gone into diversity related efforts has not moved the needle enough, right, when it comes to diversity. And so the effort right now is to think about not just bringing people into the door, but thinking about how do we make sure that they can stay and have thriving careers. I've spent a lot of time arguing about this topic in my previous life. I've called my academic life my previous life now. And one of the ways that I've tried to do is trying to reframe this conversation. We keep hearing about the leaky pipeline, right? It's as if the academic, kind of system is this robust infrastructure system that works perfect otherwise. It just occasionally has some cracks and leaks in that robust system. And so some people drop out. But when we have to be really honest about ourselves, though, not everybody leaks out or drops out, whatever that metaphor is, at the same degree. People from communities that are historically minoritized tend to leak out at a much higher proportion. So one of the works that we've done, and the thing that you heard in my intro and advanced geo, has been to really rethink how we even talk about these issues and how we address them. And one of those efforts was led to a paper in one of the Nature journals where we try to reframe this argument so that we're talking about hostile obstacle course that people from minoritized communities have to face to go through the STEM and academic systems. And the reason why that's important to me is because now we're talking about barriers that prevent people's advances. And as soon as we reframe these things as barriers and not leaks in an otherwise robust infrastructure, then it becomes the responsibility of the leaders to remove those barriers that are historically and selectively, preventing people from advancing. Coming back to my DOE role. So, and it's not just that people have to report now on what they did. They have to give us a proposal in the beginning, obviously. Then they have to report on it every year. This is also going to be part of how we evaluate labs performance. This is included in terms of what are they doing? Are they moving the needle forward in any way? And what activities are we seeing, right? So it cannot just be focused on recruiting. There has to be an effort on retention and ensuring that people are moving up the ranks, and we're seeing some change after a while. We're trying all of these things. I'm sure at some point we'll course correct based on lessons learned. This is new for DOE, right? But at least those are the efforts that are involved right now, along with others, to monitor and to think about how we can make sure that at every step, we're actually looking at changes that are happening. And if there's no change in what we're seeing, then we're failing. So we have to go back to the drawing board. But the commitment here is we'll do our best to keep looking at this in a way that we're critical of what we're doing, but we also want the community to be critical and tell us if we're missing something, right? So there's a number of opportunities. For example, the Office of Diversity and Equity at Office of Science had provided for listening opportunities. They're going to continue to do that. And there's websites and with emails of the office's lead to give us, again, tell us if we're missing something. We want the feedback. This is still new, but you'll hear about all of these assessments that we're launching along with this effort at the same time. Thank you. That's an important point, though.
We have a young lady right here.
Sit on. Hi, sorry. I'm an undergraduate at community college, and I have seen a lot of strife because I live in St. Louis. The number one, let's say number one in murders in the United States, and a lot of other things, but not something to be happy about. And there's a lot of strife going on among every community, and especially people of color, people in the Hispanic community, the Black community, the Asian community, and it's majority white in the nice neighborhoods. But the problem, I don't think, lies within the surface. Everything was created by people who weren't experts in their field. If you look back generations upon generations, these aren't experts that created this. These are travelers that wanted a better land. Like, I don't understand why we aren't starting from the bottom up and going from there, but we're starting with the surface down. This is a bottom up fight, not a top down.
Do I understand your question? I understand the structural causes of
but I don't
inequality, but
I don't understand why we are having the same people in charge. Why we're not having a panel of people, experts from every field, including ones that we don't think are important. Everyone's important. Everyone has a voice, but the people who don't have a voice right now don't have opportunities to come to places like this. They don't have opportunities to come to colleges. They don't have opportunities to come to universities and to speak to people like you. This is my first time at this. I'm 23 years old. The person that I came with first time on a plane.
no, this is the thing when we're talking about support for students. That's exactly what we're trying to do. Make sure that we're creating these opportunities and providing people the support that they need so that they don't miss on these opportunities, to address the opportunity piece part of it. I'm a little still unclear about what you meant by the first part of your question. I'm not sure I understand what the question is there.
I'm just trying to understand what you're actually doing because, sorry, not to be offensive, I do have autism, so not the best in speaking PC. sorry, but I'm just trying to understand why we aren't restructuring the system instead of just throwing money at people.
No, we're not throwing money at people.
Okay,
We're
sorry.
some of these questions need resources, but resources directed at people who have not been getting the resources. So that's an important piece of this conversation. We're not throwing money at and somehow assuming that the issue of racism will disappear or discrimination or harassment will disappear. No, that's not where we are. But there are serious inequities with resources that communities are facing. I could go through this room and ask people about their experiences in securing funding for research or even advancing in their careers. I'm pretty sure about the responses and the inequities that I would hear about and the lack of resources to be able to do their work. Because I've been in that place, right? I was a researcher. And it's not also just our personal experience. It's something that's demonstrated by study after study that has documented the inequities in resource access. The Office of Science, by definition, is an office that provides resources. That's what we do. But we're making sure that the resources that we provide reach people in an equitable manner. Thank you. Yes.
Okay. We
Oh,
have,
Jessica was going to say something.
we have time for one more question, and I'm gonna ask it.
Ah. Hey, that's you.
I took that from Fire. Fire did that the other day.
Okay.
So my question is this. So we're very glad to have you here. You are sitting in front of, one of the largest collection of Black physicists in the world.
Mhm.
So as the director of science, what is some advice that you would give the leadership at NSBP as to what we can do to better work with the Office of Science to do the kind of work that the Office of Science would like to have done?
Thank you. That's a really important question. There's many things that when I mentioned earlier that I'm hoping this is the beginning of a strong relationship. Because I feel like there's a lot of things we could be doing. An important piece to me is connecting people with the resources that we have. You all are in a position to have access to this dynamic community of researchers, some of which come from institutions that don't have strong ties with the user facilities or the labs that we steward and the opportunities that are provided there. So my hope is we'll continue to work together so that we could bridge that and make sure that the people that are members of this community can find the opportunities, and we can link them with folks in the labs and the user facilities so that they can get access to these resources. But at the same time, we want to also work with you all in making sure that we're getting this right? This is really the first time that in a major way, the Office of Science is launching this equity and inclusion efforts. If we're not doing something right, or we could do it better, we really would like to know. And I think having a close working relationship, because you all will hear whether it's working for the community or not before us, right? But at the same time, there's so many other things, but a big part of that for me is connecting the people with the resources that we're providing so that they could do their work great. That's what made a difference in my own academic career. Right. And I want to make sure that my experience is not unique. It actually should be the norm for people as much as possible, because these labs exist, these user facilities exist to serve us, but we're not taking advantage of them, largely because we don't know. I didn't know when I started. Many folks still, even when I asked about user facilities, right? Maybe some knew, but at least haven't accessed them in the ways that they could be used. So I want to make sure that we're removing those, and also if there are barriers. I mentioned earlier about proposal, the mechanics that's needed to get these proposals in place. We hear about this, that, say if you're in an Ivy League school, there's a whole offices and machineries of helping you to write these proposals needed for federal grants. If you're working at a smaller school and you have to teach 3 courses a semester in addition to doing research, or even just teaching 2 courses or whatever, it's hard. You have to do everything by yourself. So we want to make sure, is there ways we can simplify that process, right? So that that doesn't become the barrier for people to apply and to take advantage of the resources. That's a really, to me, the way I told you all about how I favor framing the conversation as barriers that we can remove. instead of just talking about, kind of these are available and that are available. But if people can't access them, we're going to end up with the same result that we did, 30 or so years ago and continuing to do so. So we want to think about how can we identify all the barriers that exist along the way and work to remove them. The removing part is on us, but it would be really great to work together to identify them and many more. But I hope this is the, I'm new to this position, right? But my hope is we'll continue to build this partnership and relationships so that we can continue to work together. Thank you.
Well, one last point from, go ahead, Dr. Jackson, real quick. We're running out of time.
Testing. I'm sorry, I lost my glasses. I can't see much. I can't see that. My name is Keith Jackson. I'm formerly of Lawrence Berkeley National Lab. I was Associate Director of the Center for X-ray Optics. And one thing I can say, I think with accuracy, the 15 years I spent there, I was able to become a millionaire because of the project I worked on. You say, how? How many here have heard of EUV technology? Okay, so that began at Lawrence Berkeley National Lab at the Center for X-ray Optics. And after I joined the lab, which was in 1992, I was the only African American with a continuing appointment there. So and toward the students, when you talk about jobs, you want to be looking at continuing jobs where you have a chance to build your career. So that's different than a postdoc. That's like a 2-year appointment. And then you got to find something else, which should be good because during your postdoc, you've written papers and things that get you to the kind of attention that you need to go to a place like Berkeley or Stony Brook or University of Chicago, all places where those facilities are based. And my thing would be, depending on what the facilities plan is for the Office of Science, what are the critical facilities to be built? Why don't you try to build one in the African American community?
Yeah,
tear down some dead buildings or burn out buildings and put in a national user facility. Or, I'm sorry, interplanetary user facility, okay? Because that's where the positions will be. And because the people sitting in those positions now have tenured appointments at some of the largest universities on planet Earth. And the other consequence of me joining Lawrence Berkeley National Lab, within 3 years, there were 5 African American postdocs. Oh, and Hakeem, he was there. You know why? Because I told them to, that's who they wanted. They wanted somebody that could send out a design for a CCD and have it built by somebody and shipped back. And then we do it instead of Lawrence Berkeley National Lab with their little 1-inch silicon wafers trying to build one. Because you ain't serious. But that's what Hakeem brought to the mix. And so needless to say, the point is people have come to Berkeley, PhD level scientists on postdocs, but none of them, well, actually one of them did very well in terms of that, because that's one part of the leaky pipeline. Not everybody wants to spend their life at Lawrence Berkeley National Lab or Argonne National Lab, particularly if they get a better offer. So that's part of leaky life. But in terms of things to be done, think about what they did at Jackson State, where they founded a PhD there in
Yeah.
physics and atmospheric sciences. Okay. And again, that creates more African-American scientists. Okay. So that's the kind of thing maybe the Office of Science should look at to address this, to place a major facility in the African-American community, regardless of what the scientists say.
Yeah, no, I think you,
I mean, because after all, if it's that important,
no, I agree with you, right? I think, I don't know how many of you realize that if you saw the map of the labs that I showed you, they're all on the coast. That's the reality of the situation, right? They're on the coast because they're in the labs, who are also mostly on the coastal areas. And that's a big part of this problem that we have with continuing underserved, communities that remain underserved for many, many years. And I don't think I have any issues in disagreeing with the point that you made, right? Because it is an important issue. Obviously, this is a really important issue.
become an advocate.
Of course, that's exactly what we are here to do, right? And so the point that I wanted to make sure to make, though, is the initiatives that we're launching right now. We all have to continue to work together, right? Our jobs is to continue to advocate for the resources that the communities tell us. And that involves making sure that we have key people in key places that bring these important concerns, right? What does that mean in reality? And in reality, what that means is, the reason why you have the associate directors for the major programs here is because we want to make sure we're tapping into this incredibly rich community here, right? For everything, including the advice that we're getting, the direction that we're going, the selection of major projects going forward, right? And making sure that these kinds of voices are part of the conversation. That's a really important one. Oh.
Oh, okay, so we'd like to once again thank our speaker for her attendance.
Thank you.
Now I want to turn it over to Dr. Carol Scarlett.
So I just have a few housekeeping items that I need to make everyone aware of. Once again, thanks to the speaker. For those of you who are students, undergraduate students, please make sure that you meet up with and participate in the evaluations. It's so important for us to get your feedback. Also, there is an evening poster session from 6 to 8. And I know many of you have already had judges come by your posters. I know there are several of you that are still waiting. So please make sure you're at that session so that we can get your posters judged. Because tomorrow, of course, we'll be giving awards for those posters. I also wanted to say that following this meeting, there's going to be some small group photos. I think Dr. Rockwood may say a few more words about the small group photos, including ones with the Office of Science Directorate. And we're going to have about a 15-minute break before we have our big science hour. Our big science hour is going to feature plasma science. This is so incredibly important for all of you worried about the environment, worried about clean energy. So you need to come here and hear about progress that's being made in plasma science, because that's one of the options that we have for clean energy, but for a lot of clean energy that we wouldn't be able to tap into otherwise. Dr. Rockwood, do you have a few words? Oh, no, this is not yet. Okay.
All right, one other quick announcement. We had a DOE traineeship program, and several of our students at NSBP have been participating in that program over the years. So during the break, while we prepare to go into a break, we want those students who are here at the conference to please come forward and take a picture with Dr. Berhe on the stage immediately during the break. Okay, thank you.
All right, that concludes this session. Thank you very much for your attendance and attention.